Good morning, everybody. How we doing? Hopefully you guys are doing all right. Hey, today we're going to read pages 125 all the way to 129. Talk about atoms, how they bond, and then bonding stuff you get into later on. We're not going to finish it this year at all, so we won't get into covalent bonds. But in high school, you guys will get into this, how they come together, how they stick together. And then periodic table, talking some more about the periodic table, getting used to the periods and the groups. And my cat found an Easter egg. Now she's going down the stairs. That's great. All right, so for you this week, today is Sunday, April 26th. Yes. And then this video will be released today. So you'll have this week to do one worksheet. That's it. There's some other assignments on there that are little things, pretty easy things to do. And then next week is the end. It is the end of your 8th grade. So, this is kind of crazy. It's kind of crazy. So you have, or maybe you have 2 weeks left. You have this week. Yeah, you have this week and then next week. So this week we're going to read these pages. You got one worksheet to do like we always do, the regular worksheets. And then next week, which will lead into May, you will be no assignments really. That's going to be the week of May 4th through 7th. You guys will, I want you guys to come on to Zoom on Tuesday and Thursday. I want you there on Tuesday and Thursday because that's going to be the end of it for everybody. So we'll say goodbye. I'm going to try to have, I want to do a karaoke, a Zoom karaoke. I would like to do that. So I'm hoping we can do that together. And then I'd like to make a slideshow of a lot of the pictures I took this year from class. So, and I'll try to find some other pictures. So if you have any pictures, I'll take them. But I will try to find some other pictures from your other classes, if they took some, or just pictures that we have from somewhere. Anyways, that's about it. So any questions, let me know. Make sure you are getting your work done, guys. Make sure you're turning it in. Some of you guys, I'm not going to tell you it was Keely, but some of you guys are doing your work and not turning it in. You have to click turn in. All right, here we go. Page 125. If you look in your book, or if you can't have a book with you, then you have on the screen next to me, there'll be a picture. You're going to see these letters, the symbols, hydrogen and carbon and oxygen, and they have these dots next to them. Okay, it's called an electron dot diagram. It shows you the valence electrons. So here we go. What's in a valence electron? Let's read about it. Okay, the number of protons in a neutral atom equals the number of electrons. Okay, remember atoms are neutral. They're not positive or negative. Well, they're neutral. They can be positive, negative. Anyways, so if you have 5 positive protons, if you have 5 protons, they're positive, but your atom is neutral, means no charge, then that means you have to have 5 negatives, because 5 positives and 5 negatives, put them together, it balances out, and you have neutral. So if you have the number of protons that you have, you will have equals the same amount of electrons as well. The electrons of an atom are found in different energy levels. You're going to get into this more in 10th grade. The electrons are found in different levels, energy levels. Electrons at higher energy levels have high amounts of energy. The valence electrons, some will say valence, the valence electrons of an atom are those electrons that have the highest energy. Valence electrons are involved in chemical bonding. That's why they're important. Bonding, coming together. The number of valence electrons in each atom helps determine the chemical properties of that element. Now, if you look at these pictures, you're going to have an electron dot diagram. Each atom of an element has a certain number of valence electrons. The number of valence electrons is specific to that element. Different elements can have from 1 to 8 valence electrons. Different elements will have 1 to 8. Okay, so this picture here demonstrates this one way, this is just one of the ways, to show the number of valence electrons. This is called an electron dot diagram. Atoms tend to be more stable. Okay, they're more stable. There's a program on the computer we mess with one day, but we can't because we're not at school. But atoms are more stable if they have 8 valence electrons. So if they have 7, they need to gain 1 more. Okay, I got birds outside. Atoms like neon, argon, krypton, xenon, and have 8 valence electrons. These elements are non-reactive, or what we call stable. Helium is stable with 2. Helium and hydrogen are going to be some exceptions we're going to look at. Helium is stable with 2 electrons. Atoms tend to form bonds so that they have 8 valence electrons and become more stable. Remember, they're wanting to be at 8. Hydrogen only needs 2 to be stable. Helium only needs 2 to be stable. Helium and hydrogen, okay? Hopefully you'll remember this over the summertime. Helium and hydrogen are stable at 2. When atoms bond, valence electrons may be transferred from one atom to another, or they can be shared between the atoms. A chemical bond is the force of attraction that holds atoms together as a result of the rearrangement of electrons between them. So the chemical bond is kind of like some of you guys in the hallway. You're a force of attraction that holds you together as a result of the rearrangement. Sometimes you have to rethink, reorganize. Sometimes you might be like, I don't want to wear deodorant. But if you do, all of a sudden you might find yourself bonding with another person, and they might like you for that. So that's a good thing. Let's turn the page. Ding! You'll have a picture of the periodic table. Okay, so the periodic table. It's hard because we're not together, but I'll put the picture up here on the screen. In period 1, okay, not period 1, group goes up and down. Group of the columns. Group 1, 2, and then again, groups 3 through 12 drop way down here at the bottom. And then you've got up here 13 through 18. So group 1 has 1 valence electron, except for hydrogen. Hydrogen is stable with 2. Group 2. Group 2 has 2 valence electrons. Okay, then if we skip 3 through 12, the transition metals, they do something different. Well, that's high school. You get it in high school. So group 1, 1 valence electron, except for hydrogen. Group 2, 2 valence electrons. Then you get into group 13, way down here. 13 through 18. Group 13, okay, 13 ends with a 3. 13 has 3 valence electrons. 14 has 4 valence electrons. 15 has 5 valence electrons. There's a pattern here. You see this? Okay, these are the patterns I was talking about 2 weeks ago, I think, when I'm just wanting you to be familiar with the periodic table when you get to high school. You need to know your transitions, you need to know your groups, your periods, you need to know your valence electrons just by looking at the group. So if I was to say, hey, how many valence electrons does nitrogen have? You can say, well, nitrogen is in group 15, so it has 5 valence electrons, which means it needs to pick up 3. Your noble gases are group 18. They're stable. They have 8 valence electrons. They're stable. So I want you to pick up on the zigzags. These are your nonmetals. These are your metalloids. Not nonmetals. They're metalloids. They have properties of both. Then you have your orange picture or your orange color on your periodic table, and that would be your gas, your nonmetals. So I got all these alarms going off. So I want you to be familiar. Your lanthanides and actinides at the very bottom. I want you to be familiar with what it looks like, what's where. There's exceptions like hydrogen's over here up in the corner. So anyways, just want you guys to be familiar with this. But just remember, valence electrons, group 1, 1. Group 2, 2. 13 through 18, 13 ends with the 3, has 3 valence electrons. Group 17 ends with the 7, because 17 ends with the 7. Then it has 7 valence electrons. Thank you, Summer. So on page 126, the periodic table is shown in this picture. It gives you information about valence electrons in atoms. The table is organized into rows. We call those periods. Periods go this way, rows. Okay, it's got columns. We call them groups. They go up and down. The atomic number of an element is the number of protons in each atom of that element. So if carbon has 6, the atomic number for carbon is 6, so it has 6 protons, has 6 electrons. The elements in the periodic table are in order by increasing atomic number. The number of valence electrons, it increases from left to right. We can kind of see that. Group 1 has 1, group 2 has 2. It's getting bigger as you go to the right. The number of valence electrons increases from left to right on the periodic table. Each period begins with an element that has 1 valence electron, except for period 1. A given period ends with an element that has 8 valence electrons. This repeating pattern means that the elements within a group, except for period 1, always have the same number of valence electrons. As a result, the elements in each group have similar properties. And we talked about that last lesson a little bit, or read it for you. There's a picture of the transformer, nickel maybe. They're similar in the same group, similar properties. Each element in period 2 goes across. So it goes period 1 and then period 2. Each element in period 2 and 3 has one more valence electron than the element to its left. That's true. Group 1 elements have 1 valence electron. Group 2 elements have 2 valence electrons. Group 13 elements have 3 valence electrons. Group 14 elements have 4 valence electrons, and so on. I love this in our book. Elements in group 3 to 12 follow a different pattern, and I think you kind of, I don't even know if you get explained to in high school on that one. Anyways, so on this picture here, it wants you to, you'll see it on my book, they're already filled in, but it's wanting you to fill in just by being able to identify the element. So if I said to you, hey, go look in your periodic table and find oxygen. Okay, I look in here, oxygen is not a metal, so I know it's on the right side of the periodic table. I find it, it's got an atomic number 8, okay? It is in group 16. So if it's in group 16, how many valence electrons does it have? And we should be able to say, oh, it's in group 16, so it has 6, because 16 ends with a 6. It's got 6 valence electrons, and then I'm able to dot them. And there's different ways that you can put these dots. Usually you go like a dot on the right, a dot up above, a dot on the left, a dot on the bottom. Then you keep going. So if oxygen has 6, you would go dot, 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 dot. That's 4. Then you'd go dot again. So now you got 2 over here. Dot again, 2 up there. So, but not, I've seen it done different ways. So, anyways, I'm sure whatever your teacher says in high school, just follow. Noble gases. The group 18 elements are the noble gases. Atoms of the noble gases have 8 valence electrons, okay, because they're in group 18, except for helium. Helium is stable. I've been telling you this all year long. There's always going to be exceptions in science. Helium is stable at 2 valence electrons. They are unlikely to gain or lose electrons or to share electrons with other atoms because they're already stable. They don't need anything. Noble gases do not react easily with other elements. Some don't even react at all. But chemists have been able to make some of the noble gases form compounds with a few other elements. All right, last 2 pages. The metals are the elements in the blue section of the periodic table. You should know that by now. They're on the far left side. Metal atoms react by losing their valence electrons. In general, the reactivity of metal depends on how easily its atoms lose valence electrons. Its electrons will move from metal to non-metal. We read that like page 100, page 99, 98, somewhere in there. We read that electrons will move from metal to non-metal. The reactivity of metals decreases from left to right. Remember, the ones, your metals on the left-hand side of your periodic table, some of them react with water, with flames and sparks. At the far left side of the periodic table is group 1, the alkali metals. Each alkali metal is the most reactive element in its period. Atoms of the alkali metals have 1 valence electron because they're in group 1. So they have 1 valence electron, except for lithium. When a group 1 atom loses an electron, it is left with a stable arrangement of 8. And that will get into your levels, your energy levels, which I don't think we'll get to this year because this is the end. So dry your eyes. Your teachers next year will understand. And I'll email them too and tell them how far we got. These electrons are in a lower energy level than the 1 valence electron that was lost. And we'll see this here in a minute. Lithium atoms are left with a stable arrangement of 2 electrons. The alkali metals are so reactive that they can even cause an explosion when they're added to water. Now your nonmetals, the elements in the orange section of the periodic table, are nonmetals. Nonmetal atoms become stable when they gain or share enough electrons to have 8. 8 is that magical number. Hydrogen atoms are left with a stable arrangement of 2. Now, the nonmetals usually combine with metals by gaining electrons. Nonmetals will gain them. Metals will transfer to nonmetals. Metals will move electrons to nonmetals. So nonmetals usually combine with metals to gain electrons. By gaining electrons. Nonmetals can also combine with other nonmetals and metalloids by sharing their electrons. That's very nice. Sharing is caring. Atoms of group 17. These are called the halogens. They have 7. Group 17 has 7 valence electrons. They're stable at 8. So they need to gain 1 more. A gain of 1 more electron will give these atoms a stable 8 electrons. The halogens react easily with other elements. So in this picture here, it shows the reaction of bromine with aluminum. And I'm trying to, I say picture. It's not. Last page of your 8th grade science book career. Here we go. I'm sad. I'm kind of sad now. It's just kind of hitting me. We're not going to be able to say goodbye. Because it's so hard. It's so hard to say goodbye. Metalloids. Metalloids lie along the zigzag line on the periodic table. So on the periodic table, you got the blue, which are metals. Then you have that zigzag line, which is greenish in our book. That's your metalloids. Then you get the orange over here. These are your non-metals, your gases like oxygen. The metalloids lie along the zigzag line between the metals and the non-metals. Atoms of the metalloids can either lose or they can share electrons when they combine with other elements. Each metalloid has some of the properties of metals and some of the non-metals. So they'll share, okay? They'll either lose or they'll share some electrons. Hydrogen, the little guy all by himself, he's placed in group 1 in the periodic table because it has 1 valence electron. But hydrogen is not a metal. It's considered a non-metal. The properties of hydrogen are very different from the properties of the alkali metals. Alkali is group 1, hydrogen is in group 1. Hydrogen is not a metal, it's a gas. But it's there because it has 1 valence electron. Hydrogen shares its electron when forming compounds with other nonmetals to obtain a stable arrangement of 2 electrons. Beautiful. Beautifully done. And it stinks because if we keep going, like you and I would start drawing these out. There's a beautiful cartoon of it. It's potassium and fluorine. It's on T-shirts. It's funny to me. I find it funny. I'm trying to think if I could take a picture of because potassium. I'm trying to think because if I can show it, well, I guess I can show it to you on the periodic table. Potassium is potassium's in group 1. It is the atomic number is 19. It's in group 1, so it has 1 valence electron. Never mind. I'm just going to show you the picture because it's a potassium atom, and he has 1 valence electron. And he says to fluorine has 7. Fluorine needs 1, and potassium has 1. So potassium says to fluorine, "I'm about to lose an electron." And fluorine says, "Are you sure?" And in the next picture, potassium has lost it. So he loses this is the negative I have in my body. If I lose the negative, I now become positive. And so now potassium has no valence electron dot diagram. Fluorine has gained an electron. Fluorine now has 8. And potassium says to fluorine, "I'm positive," because he lost the negative. Some of us need to take the negative in our life and lose it so we can become positive. So here, this is for my orange juice. That's good orange juice. Well, that's really good orange juice. All right, that is it, guys. But yes, The bonds, I would love for you guys to do the little maze on page 133. Kind of shows you how we start getting into bonds. Like sodium chloride is on page 132. We call this salt. It's just kind of cool. I like it, but you do this stuff in high school. One of the labs we do is on page 137. We try to glow a pickle. We talk about bonds and covalent bonds. We keep going. You'll see the lizard's feet. What else? I wish we could go through this together, but it is what it is, guys. I hope you're doing okay at home. Hope you guys are being good, taking care of your house, taking care of your stuff, being respectful. I know everybody's wanting to get outside. Don't become one of those kids who tries to sneak off and do to friends and does things that your parents don't want them to do. Be good, be nice, be kind, take care of each other. You can send emails, you can sell Insta, Facebook, Tweetbook pages, grams, and any of that stuff. So I'm gonna post this video. I miss you guys. I'll take pictures of the pages and put them on the screen as I'm reading. So other than that, have a great week this week. You have one assignment for me, and then I hope you guys join us on Zoom. We have 4 Zooms left, 2 this week and 2 next week. That's it. And then hopefully we'll get life back to normal by the school year. So if not, good luck online being a high schooler, or good luck walking around the new school. And yeah, just don't forget us little guys in the middle school. Okay, guys, be good. I will talk to you later.